And we're here at the SID Display Week 2019 here at the Fluxim workshop. Hello.
Hello, my name is Beat from Fluxim, and yes, we're here outside of Display Week. We have some customers joining our workshop. We're presenting our products here, and just to introduce our company, we are based in Switzerland. We have developed R&D tools since many years. We are a spin-off company from the university.
What is this?
And yeah, this is the newest measurement system for angular characterization of OLEDs.
It looks really cool. And hi, who are you?
Hey, I'm Sandra, and I'm also working at Fluxim as a tech consultant, and I'm just setting up the Phelos instrument for the workshop.
What are you doing right now, setting it up? What is this curve here?
This is the spectrum live recorded that is going through this from the OLED through the fiber into the instrument.
Is that a really special instrument for the whole industry?
Yeah, it's really necessary to characterize your emitter film, especially this is suited for OLED pixels, so you can analyze the dipole orientation, emission zone, and many more things.
This is important for everybody who works with OLED?
Yes.
Everybody?
It's crucial.
Everybody needs to have one. Is that how it works?
Yes.
And does everybody buy one yet, or how does it work? What's the status?
We just released this instrument last year as an innovation zone product, and we received first orders. Delivered the first instruments last year, and we continue to advertise. And this is a nice complement to the other products that we sell for R&D in OLEDs. Just to introduce which other products we have, we started out in 2004 with simulation software for OLEDs. Then
which one? There?
That's the Setfos. It calculates light outcoupling of OLEDs as well as current density and current voltage curves.
That was just software.
Yeah, that was just software. And then some years later, 2012, we started with measurement equipment. We call this Paios for all-in-one characterization of devices. And this we sold already many times across the world, mainly for OLED research as well as for emerging PV cell research. Then we continued with simulation software for large area display analysis. You see some AM OLED pixel array that we can simulate with this.
Nice.
And check the crosstalk issues.
That's still software also?
Yes, that's still software. So the upper row is software, and the lower row you see the measurement hardware we sell. That's Phelos we just saw live. We are demoing it just now.
That arrived 2018?
Yes.
And it's a fully mass-producible device? It's not just a one-in-a-kind sample?
No, we already delivered to several customers worldwide, all the way to Japan, for instance.
And what did the customers say about this? I mean, some of them are maybe coming here and try and get more information about it. Like
yes,
in the next
exactly.
half hour, you're going to start, right?
Yes, we are just starting in half an hour. And we already have some customers that already produce research results, like they publish scientific papers with using our tools, and that's also nice for us. That shows.
During the SID Display Week, you've had the workshops every day, or like some of the days, or how many people showed up?
Had one evening workshop already happening here with 20 participants, which are scientists working in this field and coming here for the big conference. And this is the second workshop. Today we just focus on the measurement equipment that we have, and last event we focused on the simulation software.
And what is this, Litos?
Yeah, Litos, this is the one that we are releasing this year. It's actually for accelerated lifetime testing. We can place the OLED here and heat up the chamber and test, whether it degrades faster at elevated temperatures.
That's really important to test the life of OLED, because it's one of the challenges, right?
Right, long endurance stability is still an issue, especially if you heat it up the temperature and increase the driving level, current density. And that's why we have a dedicated instrument that then can also be combined with the other instrument. So we want to let devices stress with this instrument and analyze with this instrument, which can measure JV curve, impedance, and transient.
So each of these are totally different. You can't just have one that does everything.
Yeah, but they nicely complement each other, and they all are operated by the same Fluxim characterization suite software.
So, for example, right now, if you close the door, what will happen? What are you doing?
So I'm now performing an angular sweep, so maybe you can check here. It's moving, it's rotating, and then at the same time it's recording the spectrum for every angle.
And there's something in there, like a sample of some kind of OLED in there?
Yes.
What is this?
Phosphorescent blue OLED.
Blue OLED.
former collaboration.
So it's just a little sample of something there. It's not connected or powered on or anything, right?
Powered. These two probe tips are connecting cathode and anode.
Ah, so you're actually powering up the OLED.
Yes. There is now 0.2 milliamps flowing through the OLED.
So it's the whole point is you want to see it in action and see what happens.
Exactly. We want to see the angular dependence of the OLED emission.
Nice. So you have the whole system, so you can easily set up all these different. What are these different samples?
So these are just different OLEDs with some different layer thicknesses, and this one are PL heads. So instead of putting an OLED on top, we can also put a PL film, so a single emitter film, and then put this.
Can we look around? What is going on here?
So there's a hole, and here inside there is a UV LED with 275 nanometer wavelength. And then you just excite your film from the top through this hole, and then you measure also the angular dependence of the photoluminescence.
But is that an OLED or something else?
Oh, this is just a single emitter film, so you
just film that goes on top of the, like all these films that polarizes
which
and
is
stuff?
part of the OLED itself, actually. It's a crucial film inside the OLED which will emit the light. And inside this film, there is an orientation of molecules that has to be optimized.
So the best way to measure is put in darkness? Is that what you do?
Yes.
Otherwise you get interference from the surrounding light and stuff?
Not really interference, but you just have more noise, like background.
Ah,
signal.
the noise. So that's cool. So how is it to work with the Fluxim? So what kind of stuff do you do?
Well, we help R&D teams worldwide to investigate their OLEDs and solar cell and try to improve or help them to improve their OLED devices and extend the lifetime.
Cool. And so who's going to come here, this workshop?
We have customers from basically pretty much the big companies that actually produce the next generation displays, OLED TVs from Asia, from the US, and maybe
all
the big ones, yeah.
For smartphone and TV and everything, or
yes,
just smartphone?
For both, actually. So mobile phones.
Any OLED?
Any OLEDs, whether for mobile phones or for large TVs.
Do you have any influence in the way people are going to maybe be using quantum dots with OLEDs?
Indeed, that's an interesting topic. We started to use our tools also for quantum dot characterization. Where maybe we have a film around. No, actually we have here a poster presentation. We just showed that one last night, where some other Swiss company that we collaborate with, Avantama, they sell the perovskite quantum dots, which can be used in combination with blue backlight. In this case, we measured OLED plus QD down conversion film with our instrument, the one you just saw. And we also extended our software Setfos to simulate the down conversion from blue to green. And with this simulated data, we can then compare the measured angular luminescence spectra with the simulated spectra. And thanks to this good agreement, this is an overlay of the data, you can trust the numbers we get out, crucial film properties like concentration of quantum dots.
And you can also work with the other suppliers of quantum dots, like Nanosys, for example?
Exactly. So basically, it's just we provide the tool to measure and analyze these film that contain the quantum dots from Nanosys or from any QD material supplier.
And that's going to be on the glass, or is it going to be on the top? How does it work when you put quantum dot with OLEDs? Where does it go?
Yeah, there's a plan that quantum dots would be directly deposited on a blue OLED, basically pixelated, such
just
that
each blue OLED gets some quantum dot.
Yeah, the advantage would be cover OLEDs throughout the whole display as blue OLEDs, and then selectively add green and red quantum dots by inkjet printing, for instance, to achieve the RGB.
I was really impressed with some of the printed OLEDs I've seen at this show. Very impressed with the JDI. They were showing some. It looked like mass production OLED, but it was printed. How cool is that?
That's pretty amazing to see that also it's going towards flexible, not just glass-based and rigid, but a lot of progress in flexible displays as well.
And you were totally involved in that, the printed OLED stuff?
Yeah, we help to improve the speed of innovation to get the next generation display faster to the market by using very efficient tools that are easy to use, that the scientists don't have to develop their own measurement setup and their own simulation software, that just use our software to advance their technology faster. And yeah, these are the flyers of our products. That's the newest one. We didn't bring it today, but we have some pictures brought with us. And here, that's the stress testing system.
What's happening in those 4 things
In
here?
these 4 boxes, we have a climate control chambers where we can control the temperature and also the humidity and gas flow.
Oh.
And this, test various conditions of operation and see whether the OLEDs are really stable at different conditions.
Nice. So what's the status now? Is everything set up for the workshop? Or
Yes, everything's ready.
Everything's ready. So what were you doing the last 10-15 minutes, for example?
So I'm just testing one device, full measurement routine. So what we don't only do, we don't just do spectral measurements, but we also record IVL curves. It's already over.
It's finished?
So
it's too quick.
You already have some data on the IV behavior of this device, and now it's recording the angular dependence.
So how is it to work in this industry with the displays and OLEDs and stuff? Is it cool?
Yeah, it's really exciting. I mean, everyone that has this smartphone product is one of our customers, and we're really proud to do that.
Why is it a Swiss company that knows how to make this and not like some from somewhere else?
Well, because we had a bright guy that was
Like
starting the business.
It's a precision engineering, right? This stuff.
I happened to be in the field doing my PhD many years ago, and I was addicted to this topic, OLED technology. Back in 20 years earlier, it wasn't
Very early
industry
OLED.
ready. Yeah, it was still in the early stage, and over the years I was always in this field, and I discovered that there are challenges in research that could be maybe faster solved by using enabling R&D tools. Yeah.
So what's happening in the future? What's going to happen in the future of your company?
We try to follow the trends of the industry because the display technologies are fastly emerging and changing, and so we come also to such scientific conferences to see the latest trends and to think how can we adapt our R&D tools for the next generation displays, because there are many funny combinations coming up, OLEDs with down conversion, films and things like that. So we need to adapt and be in touch with our customers and gain new customers.
So thanks a lot for this demonstration. I think I need to stop because your workshop is going to start very soon. So thanks a lot.
Thank you very much for visiting.
Thank you.
Bye.